Hello, here we are with Learning with Mr. Neff. We are learning about multiplying binomials and trinomials here. So three real targets we have here. I can multiply two binomials using the distributive property / FOIL method. You'll see what I mean when I talk about that. I can multiply a binomial and a trinomial using the distributive property. And I can multiply binomials using a table. So we're going to look at the same thing in three different ways. All right, so it's basically, if you understand the distributive property, you're going to be in real good shape. And I won't really have to share too much, but I'm going to give you a couple different looks again, help you understand the different ways to look at it and understand it. All right, what's a binomial? It is a monomial, or is a polynomial with two monomials. 2x plus 5 is an example of that. Those are two distinct terms, so it's a binomial. Trinomial has three distinct terms, and therefore that's why you see that example right there, 3x squared plus 5x plus 5. So here, I have all the work done ahead of time. It makes it a little bit easier to explain it. So I'm going to show this to you. Okay, I got an extra box here, I think. All right. So let's look at, this is really, if we're looking at from a FOIL, all right, it's really distributive property. And so I teach it that way, but this is, you'll hear people talk about FOIL. They'll say use FOIL or FOIL this, and that's when you're multiplying two binomials. So first, outer, inner, last is the method that you're looking at. So if you look in the green here, we're going to look at this 2x. The first thing you would distribute is everything in here is, every term is distributed to the other term. So if you really look, you got 2 and 2. So it's going to be 4 different terms. So 2x times 4x is our first thing. That's our first term. Of course, that is 8x squared. So we have done the first term. Outer is the 2x and the 3. So we're going to multiply those. And we get 6x. Inner is 5 times 4x. We're going to now distribute that. There are inner 5 times 4x. And then lastly, 5 times 3. And there we see this expression right here. Now, you see 4 terms, but really it's not going to have 4 terms because we're going to simplify those middle terms. Oh, if I can get that disappear. So we have 8x squared plus 26x. Always watch your signs too here, right? When you combine. Plus 15. That is simplified. That's what we FOILed that out in that particular one, multiplying a binomial with another binomial. All right, let me look here. All right, now we have you can try this. And I threw one in here. It's a little bit different look, and that's that x squared and x. You don't see that a lot of times. And so x squared, you're going to first, outer, inner, last. So go ahead. If you want to pause this, go ahead and then try it. See if you got it right. That's why it's on here. So pause it, see if you got it right. Or just keep listening. So the first term is x squared. And excuse me, x squared times x is x to the third. The next term, it would be 4x squared, because the outer term minus 4x squared. And the next term would be a positive 1x. And then lastly, the last term is negative 4 then. First, outer, inner, last. Now that is simplified because each of these now are unlike terms and they can't be combined or simplified. So that's really example 1. All right, the next thing you're looking at here, you have a trinomial times a binomial. Okay, and now this is where FOIL doesn't work because you first, outer, inner, last. That's 4 things. Well, here we have 3 and 2. Oh, 3 times 2 is 6. So if we just think about these every single time as distributive property, you should be in good shape. So we're going to take the 6x squared, and that's going to go to 2 terms. 2x will go to 2 terms, the same 2 terms, and 8 will go to the same 2 terms. So as you can see, 6x squared times 3x, 18x to the third. 6x squared times the negative 7, really, is what it is. So it's minus 42 or plus negative 42x squared. Then now we go to the red. 2x times 3x is 6x squared. Then you go to 2x times 7 or minus 7, you have minus 14x. And that's plus negative for combining purposes. And then you go to the last one. 8 times 3x is 24x. And then 8, 7 there with the minus sign is minus 56. Then you have like terms. You have the x squareds to combine. Here, negative, right there, that's when I say negative 42x squared plus 6. That'd be, so it's really think of it as 42. You want to know the difference, but the bigger one's going to get the negative here. So 42 minus 6, if you think of it that way, is 36, but it's going to be negative 36x squared. And then 6x squared minus 14x again. What's the difference? The difference is 8, and the negative is the stronger of the two. And it's going to have a negative. Oh, I said that wrong. I looked at the wrong thing because I was looking at red and red. All right, so someone probably caught that. What is it? Negative 14x combined with 24x is 10x when I combine that. So excuse me on that slip. 18x to the third minus 36x squared plus 10x minus 56 is the simplified version of that. One for you to try, and really just pause it. I won't give as much explanation here. I want you to pause it and try it out, especially my students at home there working on that. Try it out and then see what you will end up getting here, okay? Now, again, you have 6 terms. I'm going to show you those 6 terms, and you'll pay attention to negatives. That's what you'll see right there. I'll pull that off to the side. Negative 6x to the third minus 12x squared minus 2x squared minus 4x plus a negative, or minus 16x and minus 32. But I like to do plus negatives when combining like terms. Again, the two middle terms you're going to combine again. Now you have negative and negative in the middle. That's negative 14x. It's going to get bigger negatives. Now don't mess this up this time. Negative 4x and negative 16x together is a negative 20x. And so all said and done, you can see that the answer is negative 6x to the third minus 14x squared minus 20x minus 32. A little review here. That is a cubic polynomial. This is a polynomial to the 4th degree. A cubic, right there, polynomial to the 4th degree. I said that wrong too. 4-term polynomial. Well, we'll keep rolling here. So it's a 4-term polynomial that is cubic by the degree. It's to the 3rd degree, so that's the biggest. Same thing with the one here. It was a 4-term polynomial that was cubic. Just to remind you of some of our words. Even that one there, that was cubic as well. This one was actually a trinomial to the 2nd degree. Just reviewing some vocab there for you. All right, last thing, simplify using a table. Now, again, you already understand it, so you're good, right? I just want to show you this look. Sometimes this does help people understand it better. There's a few people specifically this really helps give a light bulb. Also, I think the reason why they call these quadratic when they go to the 2nd degree, it's a quadratic problem. All right, trinomial to 2nd degree is quadratic. You see 4 parts that are made from this table. See how you have 2x plus 4 and then x plus 3. So make it like a pool is what I've seen this done before. If you can picture this being a pool, really weird. I don't know why there'd be yellow on the pool. Maybe that's not a good example here. Sorry, thinking about that. Yellow pool. The blue one looks okay. The green, algae, black, I don't know. But yeah, so 2x times x is what we're saying. That's the area of that section of the pool, the shallow end, where the kids might pee in it. Okay, 2x squared. All right, right there. That's what that is, okay? The next section of the pool over 3 times 2x, that section is 6x. All right, now over here, again, you have the same idea, 4 and x, right there. I don't remember why I wrote 1 and 2 there, or the sections of it, I think it was. 4 times x then is 4x. And then lastly, 4 times 3 is 12. So then the answer, okay, I got to move this so you can see. All right, the answer is 2x squared plus 10x plus 12. When I combine the sections, these two sections right here, they're combined together, and I get that right there simplified. So that's another way to look at that. It's the same thing we did in example 1. Again, just different ways to look at it. All right, give you one to practice here. Again, it's like FOIL 2, same idea here. I'm going to let you do this. So if you use a table here, you draw it off to the side like this and you just fill in the blanks. So if you want to do that, pause that. Give yourself a chance. I'm certainly going to help you, especially if you're struggling. So 2x times 3x, 6x squared. All right, then you have 2x times 3x there. And you have 6x. Then 4 times 3x, 12x. And then lastly, 4 times 3 is 12. Combine your middle that are like. So there it is right there. And then lastly, when you combine the middle terms here, you have a quadratic trinomial, 6x squared plus 18x plus 12. Okay, I think that's all we have time for today on Learning with Mr. Neff. Oh, yeah, but looking ahead, hey, I did have a slide. Looking at special binomials, these are two different ones that we'll look at more in the next section. This is a special case you'll want to know later on. It's important to understand what these are. This is a square of a binomial, and this here is the product of a sum and a difference. So that's just what we're going to do, two special binomials that we'll deal with later on that are important. Now, I think that is actually all we have time for on Learning with Mr. Neff. It's been great, and I hope you got a lot out of it. Bye-bye.